Have you ever looked up at the night sky and witnessed something so strange, so breathtakingly beautiful, that it left you completely speechless? Maybe you caught a fleeting meteor blazing across the darkness, or noticed a planet shining unusually bright, and in that quiet moment, you felt a profound connection to the vast, mysterious cosmos above. These aren't just random occurrences, they're invitations, cosmic winks from a universe full of wonders waiting to be discovered. And what if I told you that some of these celestial events are so rare, so spectacular, that witnessing one could truly be a once-in-a-lifetime experience? Today, we're embarking on an epic journey through time and space to explore the top 25 rare astronomical events you shouldn't miss. From dazzling meteor showers that rain fire across the heavens to planetary alignments that ancient civilizations regarded as divine messages, the universe stages performances that defy imagination. Some of these events unfold over mere seconds, while others grace our skies only once every few centuries. Each one tells a story of cosmic collisions, gravitational dances, and the incredible forces shaping everything we see when we gaze upward. This isn't just a countdown, it's a front-row ticket to the greatest shows the cosmos has to offer, moments where science and magic intertwine right before our eyes. So whether you're an avid stargazer with a telescope by your side or someone who simply loves to look up and wonder, this video is your guide to experiencing these marvels for yourself. We'll uncover when and where these events will occur, what makes each one so extraordinary, and how you can prepare to witness them. Get ready to mark your calendars and open your mind, because what you're about to discover will leave you in awe of just how alive and active our universe truly is. Let's begin. Beginning our countdown at number 1 is an event so powerful, so utterly transformative, that it has stopped wars, inspired legends, and brought seasoned astronomers to tears: the total solar eclipse. This is the ultimate celestial spectacle, a perfect cosmic coincidence that unfolds right before our eyes. It happens because our moon and our sun appear almost exactly the same size in our sky. The sun is about 400 times wider than the moon, but it's also roughly 400 times farther away. This stunning match is what allows the moon to completely block the sun's brilliant face, but only for those standing in the narrow path of totality. If you're outside this path, you'll only see a partial eclipse, which is interesting but pales in comparison to the full experience. Inside the path, the world undergoes a metamorphosis. The light doesn't just fade like dusk, it becomes an eerie, silvery gray, and the temperature plummets. The horizon glows with a 360-degree sunset. Animals are utterly fooled by this false night. Birds stop singing and return to their nests, crickets begin chirping, and flowers might even close their petals. And then, in the final seconds before totality, the last brilliant rays of sunlight stream through the valleys on the moon's surface, creating the breathtaking diamond ring effect, followed by Bailey's beads, shimmering points of light around the lunar limb. Then it happens, totality. The moon slides completely in front of the sun, and day becomes night. The black hole in the sky where the sun should be is surrounded by the sun's ethereal white corona, its wispy outer atmosphere shimmering and dancing into space. You can look directly at it with your naked eye, safe to take in every stunning detail. Stars and planets become visible in the middle of the day. The experience is visceral, humbling, and profoundly emotional. It's a reminder of our precise place in the universe, a moment of pure, awe-inspiring connection. To witness this yourself, planning is essential. The next total solar eclipse visible from North America crosses Mexico, the United States, and Canada on April 8, 2024. After that, you'll have to wait until August 12, 2026 for one that graces the Arctic, Spain, and Iceland. Always use certified solar viewing glasses to watch the partial phases leading up to and after totality. But when the moon completely covers the sun, that's your signal to take them off and soak in the incredible view. This isn't just an event you see, it's one you feel, a memory that will stay with you forever. Moving from the moon's grand performance to a far more subtle and patient cosmic alignment, we arrive at the transit of Venus, an event of profound rarity and immense historical importance. This phenomenon occurs when Venus passes directly between Earth and the Sun, perfectly aligning so that the planet appears as a small, perfectly round black dot inching slowly across the face of our star. Unlike the dramatic daytime darkness of a total solar eclipse, it is a delicate, almost minimalist spectacle. It requires a telescope equipped with a proper solar filter to see it safely, but for those who do, it's a sight that connects us directly to the great astronomers of history. The true wonder of a Venus transit lies in its incredible infrequency. These events happen in pairs separated by 8 years, but with over a century gap between each pair. The most recent transits occurred in 2004 and 2012. If you missed those, you'll need remarkable longevity for the next chance. The next pair won't grace our skies until December of 2117 and 2125. This makes witnessing a transit a genuine once-in-several-lifetimes event, a celestial occasion that most of us will only ever see in photographs or historical accounts. This rarity is precisely what made transits so critical to the history of astronomy. For centuries, scientists understood the relative distances between planets but lacked a true measurement for the absolute scale of our solar system. The transit of Venus provided the key. By observing the event from widely separated locations on Earth, astronomers could use the principle of parallax, the slight difference in the apparent path of Venus across the Sun, to triangulate the distance between Earth and Venus with unprecedented accuracy. This single measurement, known as the astronomical unit, became the fundamental ruler for the cosmos, allowing humanity to finally calculate the true distances to all the planets and grasp the immense scale of our celestial neighborhood. The great expeditions launched to observe these transits read like adventure novels. In 1761 and 1769, nations dispatched their finest minds to the far corners of the globe from Tahiti to Siberia, braving treacherous voyages and uncertain conditions, all for a few precious hours of data. These efforts, though fraught with challenges and sometimes optical illusions known as the black drop effect, eventually yielded the data needed to make those first accurate calculations. So when you look at an image of that tiny black dot on the Sun, you're not just seeing a planet, you're seeing a pivotal moment in our understanding of the universe, a key that unlocked the dimensions of our solar system and set the stage for all of modern astronomy. While the precise alignments of planets and our moon offer predictable wonder, the universe also delivers moments of pure, unpredictable spectacle. And nothing embodies that thrilling surprise better than the arrival of a great comet. This is our number 3 event, a celestial visitor that can transform the night sky into a stage for one of nature's most breathtaking and ethereal displays. Unlike the scheduled performances of eclipses or transits, a great comet arrives unannounced, a dazzling icy wanderer from the distant outer solar system that suddenly becomes the brightest object in the heavens aside from the sun and moon. So what exactly elevates a regular comet into the legendary status of being great? It boils down to a combination of 3 key ingredients: its intrinsic brightness, its proximity to the sun, and its proximity to Earth. A comet is essentially a dirty snowball, a nucleus of ice, rock, and frozen gases. As it approaches the inner solar system, the sun's heat causes this nucleus to erupt, vaporizing its ices and releasing enormous clouds of gas and dust. This forms the glowing head, or coma, which can grow to be larger than a planet and often gives birth to the iconic tail that stretches millions of miles across space. When a comet's orbit brings it exceptionally close to both the Sun and Earth simultaneously, This entire process is supercharged, resulting in a brilliance that can be seen easily without any optical aid, even from light-polluted cities. History gives us perfect examples of what to expect. Comet Hyakutake, which graced our skies in 1996, is often called the Great Comet of 1996. It passed incredibly close to Earth, and while its nucleus was relatively small, its proximity allowed observers to see its stunning, bluish-green ion tail sweep across nearly half the sky. It was a swift and graceful visitor, unforgettable for those who saw it. Then, just 1 year later, Comet Hale-Bopp arrived. It was the opposite in many ways. It never came particularly close to Earth, but it had a gigantic and incredibly active nucleus. For a remarkable 18 months, it was visible to the naked eye, a constant fixture with two distinct tails. A straight, blue ion tail pushed directly away from the solar wind, and a broad, curved dust tail reflecting sunlight. It was a patient, majestic sight that felt permanently etched into the heavens. The most magical aspect of a great comet is its unpredictability. While we know of many comets with long-period orbits, we often cannot accurately predict how bright they will become until they near the Sun. A faint comet discovered today could erupt into a magnificent spectacle as it gets closer. This means that the next great comet could be lurking in the depths of the solar system right now, already on its long journey toward us. It's a powerful reminder to always keep looking up and to stay connected with astronomy news. When the alert goes out that a potential great comet is arriving, you'll want to be ready. Find a dark sky, give your eyes time to adjust, and prepare to witness a cosmic masterpiece, a fleeting, beautiful reminder of the dynamic and ever-changing nature of our solar system. While a total lunar eclipse is always a stunning event, there exists a special, premium version of this celestial show that offers an even more dramatic and prolonged experience. This is the central lunar eclipse, sometimes called a perfect eclipse, and it earns the number 4 spot on our list for its incredible duration and intensity. During any total lunar eclipse, the full moon passes through Earth's shadow, which is composed of 2 parts, the lighter, outer penumbra and the darker, inner umbra. In a typical total eclipse, the moon might glide through the northern or southern edge of this umbral shadow. But during a central eclipse, the moon's path takes it directly through the very heart, the deepest and darkest center of Earth's umbra. This precise alignment has 2 spectacular consequences. First, and most noticeably, it maximizes the duration of totality. While a standard total lunar eclipse might last around 45 to 50 minutes, a central umbral eclipse can plunge the moon into darkness for an astonishing 100 minutes or more. This gives you well over an hour and a half to watch the fully eclipsed moon hanging like a mysterious coppery orb in the star-filled sky. Second, this central passage results in a much deeper and darker eclipse. Because the moon is immersed in the densest part of our planet's shadow, the typical bright, coppery red color can transform into a deeper, smokier crimson or even a dark grayish brown, making the moon appear almost like a ghostly, 3-dimensional sphere suspended in the void. This famous blood moon effect, common to all total lunar eclipses, is a beautiful demonstration of atmospheric optics. The sun is directly behind Earth, so you might think the moon would simply vanish in the shadow. Instead, sunlight skims around the edge of our planet, passing through the blanket of Earth's atmosphere. Our atmosphere acts like a lens, bending this light inward to illuminate the moon's surface. But it also acts like a filter. The gases in our air scatter the shorter, bluer wavelengths of sunlight. This is the same Rayleigh scattering that makes our sky blue. What remains and gets projected onto the moon are the longer, redder wavelengths. It's the combined light of every sunrise and sunset happening around Earth at that very moment, casting a warm, rusty glow upon the lunar surface. For those eager to plan for this extended celestial event, the timeline is on your side. Central umbral eclipses are not nearly as rare as a Venus transit. A notable recent one occurred in July of 2018, visible across much of the world. Looking ahead, mark your calendars for the night of June 26, 2029, when a central total eclipse will be visible across the Americas, Europe, and Africa. Another excellent opportunity will arrive on July 7, 2047, offering a fantastic view for observers in Australia, the Pacific, and the Americas. The best part about lunar eclipses is their accessibility. No special equipment is needed. You can watch the entire event unfold comfortably with your naked eye, through binoculars for a closer look at the color changes, or with a telescope to see the subtle movement of the shadow across the lunar craters. It's a patient, peaceful, and profoundly beautiful reminder of our place in a dynamic solar system. After the deep, patient glow of a lunar eclipse, the sky offers a very different kind of performance, one of intimate, dynamic dance. This brings us to our number 5 event, the Very Close Planetary Conjunction. Picture two brilliant, star-like points of light, normally separated by a wide expanse of sky, slowly drawing closer night after night until they appear to nearly touch, creating a dazzling double beacon that captivates everyone who sees it. This is the magic of a conjunction, an optical illusion born from our perspective here on Earth. And when the planets get exceptionally close, it becomes one of the most beautiful and accessible sights in all of astronomy. The mechanics behind this celestial meetup are a fascinating dance of orbital speeds and perspectives. Our solar system is largely flat, with all the planets orbiting the Sun in roughly the same plane called the ecliptic. From our moving vantage point on Earth, we see the other planets tracing paths along this same narrow band in our sky. A conjunction occurs when two planets from our line of sight share the same celestial longitude, making them appear right next to each other. But a very close conjunction, where they are separated by less than the diameter of a full moon, is a much rarer and more precise alignment. It requires the faster-moving planet to pass the slower one at just the right moment and at just the right angle, creating that breathtaking moment where they seem to merge into a single, extraordinary light. We were all given a magnificent modern example of this phenomenon in December of 2020 with the great conjunction of Jupiter and Saturn. Dubbed the Christmas star, these two gas giants hadn't appeared that close together in nearly 400 years since 1623. For weeks they grew closer in the southwestern twilight sky. Then, on the night of closest approach, they were separated by just 1/10 of a degree, a mere 1/5 the width of the full moon. Through a telescope, the view was utterly surreal. Both planets and their collection of moons were visible in the same eyepiece field of view, a sight so rare it feels like a cosmic privilege. Jupiter, with its cloud bands and 4 Galilean moons, sat just above the glorious, ringed spectacle of Saturn. It was a perfect miniature of our solar system, a moment that connected ancient astrologers who saw portents in the sky with modern scientists who understand the orbital mechanics at play. Capturing this event is a fantastic project for any photographer, from beginners with smartphones to experts with telescopes. The beauty of a conjunction is that its two bright subjects are easy to find. For a simple but effective shot, use a tripod and a camera with a decent zoom lens. Compose your shot to include an interesting foreground element, like a tree silhouette or a distant horizon, to add a sense of scale and place. Use a remote shutter or your camera's timer to avoid blur from pressing the button. For a more advanced approach, attaching your camera to a telescope can reveal stunning details, showing the planets as distinct worlds sharing a moment in time. The next truly exceptional close conjunctions might be years or even decades apart, which makes each one a special occasion worth preparing for. It's a powerful reminder that the planets are in constant motion, and sometimes their paths create a brief, beautiful masterpiece just for us. While the delicate dance of planets offers a predictable grace, the universe is also capable of unleashing a celestial fireworks display of raw, breathtaking power. This brings us to our number 6 event, the Meteor Storm. Forget the gentle, sporadic streaks of a typical shower. A storm is an entirely different category of event, a true tempest of light where the sky itself seems to crackle and fall. Imagine not just a few meteors per minute, but hundreds, even thousands, every single hour. It creates the overwhelming sensation that you are flying through a cosmic cloud, with fiery trails crisscrossing the entire vault of the heavens in a silent, spectacular frenzy. The key distinction lies in the numbers. A reliable annual meteor shower, like the Perseids or Geminids, might produce a zenithal hourly rate of 80 to 120 meteors under perfect conditions. That's a wonderful show, but a storm is defined by a rate of at least 1,000 meteors per hour, and the greatest events have far exceeded that. This incredible intensity is born from the debris trails left behind by comets. As a comet orbits the Sun, it sheds a cloud of dust, rock, and ice particles along its entire path. Normally, Earth's annual passage through this diffuse stream of particles gives us our yearly showers. A storm, however, occurs when our planet plows directly into an unusually dense, narrow filament of debris, a concentrated ribbon of rubble that was ejected from the comet during a single, specific pass, perhaps centuries ago. History provides us with legendary accounts that sound almost mythical. In November of 1833, the Leonid meteor storm erupted over North America. Witnesses described it as a true night the stars fell, with estimated rates soaring past 100,000 meteors per hour. It was so intense that it sparked widespread panic and religious fervor, but it also marked a pivotal moment for astronomy, helping scientists begin to link meteors directly to comets. A little over a century later, in 1966, the Leonids delivered another stunning performance. Observers in the western United States were treated to a peak rate of thousands of meteors per minute, so many that it became impossible to count them individually. People simply described it as a meteor blizzard, with the sky appearing to weep trails of light. Predicting these storms with absolute certainty remains one of the great challenges and thrills of modern astronomy. While we know the orbits of many comet debris trails, the exact density and distribution of particles within them can be difficult to model. Forecasts can point to a potential storm, but its true intensity is often revealed only as it happens. This means that to witness one, you need a blend of preparation and luck. The best advice is to stay informed about the predictions for major showers like the Leonids or the Perseids. Astronomy organizations and websites will often issue alerts if a particular year's shower has the potential to become storm level due to Earth's anticipated passage through a dense debris filament. When such a forecast is made, that's your cue to clear your schedule, find the darkest possible sky, and prepare for a sleepless night. You'll want a reclining chair, warm blankets, and simply your own wide-eyed view. No telescope or binoculars are needed for an event this vast. Just lie back and let the entire sky fill your vision, ready for the possibility that the heavens might, for one incredible night, truly come alive. Shifting from the grand, all-sky spectacle of a meteor storm to a far more intimate and precise celestial drama, we arrive at one of the most thrilling events an observer can witness, the occultation of a bright star or planet by the moon. This is our number 7 event, a display of celestial motion so direct and visceral it feels almost personal. An occultation is simply an eclipse in its most basic form, one object passing directly in front of another, blocking it from view. In this case, our moon, as it journeys along its orbit, glides silently in front of a distant star or a wandering planet. For those positioned along a very narrow path on Earth, the result is a breathtaking performance of sudden disappearance and reappearance, a cosmic game of peek-a-boo played out against the blackness of space. The sheer speed of the event is what makes it so startling, particularly for stars. Because stars are effectively pinpoints of light from our perspective, their vanishing act is instantaneous. One moment, a brilliant star like Aldebaran or Regulus shines defiantly right next to the dark or bright edge of the moon. the next moment it's just gone. It doesn't fade, it doesn't flicker, it is simply extinguished by the moon's rocky limb in a fraction of a second, as if a switch was flipped. The reappearance on the opposite side of the moon is just as dramatic, the star bursting back into existence out of the void. When a bright planet like Venus or Jupiter is the target, the event is slightly different but no less incredible. Instead of a pinpoint, you watch the planet's disk take several seconds to slip behind the moon, a slow, graceful fade that highlights its true size and shape before it winks out completely. This precision is what makes occultations so much more than just a beautiful sight. They are powerful scientific tools, because the timing of these disappearances and reappearances can be measured down to a fraction of a second by observers at different locations. These events allow amateur astronomers to contribute to real science. By comparing their precise timings, they can help map the exact topography of the lunar limb with incredible accuracy, revealing mountains and valleys on the edge of our moon that are otherwise invisible from our viewpoint. Furthermore, if a star is part of a binary system too close to be split by any telescope, its occultation can reveal its secret. As the moon's edge covers the star, the light may not vanish in one clean step. Instead, it might dip slightly, then again, as it first covers one star and then its companion, revealing the presence of a double star system directly. To witness an occultation yourself, you'll need to plan carefully. The paths of visibility for these events are incredibly narrow, often just a few dozen miles wide. Websites and apps from astronomical organizations provide detailed predictions and maps showing exactly where on Earth you need to be to see the moon cover a specific star or planet. The best events to look for are occultations of bright planets or first-magnitude stars, as these are easy to spot even in less than perfect skies. All you really need is a pair of steady binoculars or a small telescope, though the naked eye can suffice for the brightest targets. The key is knowing exactly when and where to look, finding yourself in that narrow path and watching a celestial light vanish before your eyes connects you directly to the clockwork mechanics of our solar system in a way few other events can. It's a personal, hands-on demonstration of orbital motion, a moment of pure cosmic clarity. But of all the events we can witness from our tiny world, perhaps none carries the profound weight, the sheer cosmic significance of a naked-eye supernova. This is our number 8 event, and it represents the ultimate celestial farewell, the violent, magnificent death of a star in a cataclysm so powerful it can, for a few glorious weeks, outshine entire galaxies. To see a new star appear where none existed before, to watch it blaze in the night with a light that traveled for centuries just to reach your eyes, is to witness a chapter in the grand story of the universe itself, a story of creation and destruction written in fire. The science behind this spectacle is as awe-inspiring as the event itself. A supernova marks the final, dramatic end for a massive star, one at least 8 times heavier than our Sun. For millions of years, such a star has been a cosmic forge, fusing lighter elements like hydrogen and helium into heavier ones in its core. This process creates the energy that makes it shine, but it's a battle against gravity. Eventually, the star runs out of fuel for fusion. With no outward pressure to hold it up, the core collapses in upon itself in less than a second. The rebound from this incredible collapse triggers a shockwave of unimaginable power that blasts the star's outer layers into space at nearly 1/10 the speed of light. For a brief time, the energy released in this explosion can outshine the combined light of every other star in its host galaxy. Historically, these events were seen as portents, mysterious and terrifying new stars that challenged humanity's understanding of an unchanging heavens. In 1604, the great astronomer Johannes Kepler observed a supernova so bright it was visible in the daytime for over 3 weeks. Now known as Kepler's supernova, it occurred within our own Milky Way galaxy, a relative stone's throw away at 20,000 light-years. Its sudden appearance fueled debates and scientific inquiry during a time when the heavens were thought to be perfect and immutable. but we have a far more recent and intimate example. In February of 1987, a star exploded in the Large Magellanic Cloud, a small satellite galaxy of our own Milky Way. Designated SN 1987A, it was the closest and brightest supernova seen in nearly 400 years, visible to the naked eye from the southern hemisphere. For months, astronomers around the world trained every available telescope on it, gathering priceless data that transformed our understanding of stellar death, the creation of heavy elements, and even the behavior of subatomic particles called neutrinos that flooded from the explosion. This rarity is what makes the prospect of a new galactic supernova so electrifying. Within our own Milky Way, astronomers estimate that a star goes supernova perhaps once or twice every century. But most of these are hidden from our view by vast clouds of interstellar dust. A supernova bright enough to be clearly visible to the naked eye, like Kepler's, is likely a once-in-a-millennium event. The thrilling, almost unsettling truth is that the next one could happen at any moment. The light from an explosion that occurred 100 or 1,000 years ago could already be on its way to us, destined to arrive tonight, next year, or a century from now. This is why astronomers encourage everyone to become a casual sky watcher. Familiarize yourself with the major constellations and asterisms. If you ever see a brilliant, unfamiliar star where one shouldn't be, you might be the first human in centuries to witness a galactic supernova. The most important step you can take is to immediately report it to a local astronomical society or an online forum like the American Association of Variable Star Observers. Your simple report could trigger a global alert, ensuring that the world's most powerful instruments swing into action to capture every precious second of a star's final, glorious act. While many of the events on our list require precise timing and a specific location on Earth, our number 9 phenomenon can transform the entire sky above you into a living, breathing work of art, even if you live hundreds of miles from the Arctic Circle. This is a major aurora display, a geomagnetic storm so powerful that the legendary northern and southern lights descend from their polar homes to dazzle observers at surprisingly low latitudes. Imagine looking up to see not just a faint glow, but vivid, dancing curtains of emerald green, vibrant crimson, and deep royal purple rippling and swirling directly overhead, a silent symphony of light that feels both immense and intimate. This incredible spectacle is born from a tempest 93 million miles away on the surface of our Sun. During periods of high solar activity, the Sun can unleash enormous bubbles of superheated plasma and embedded magnetic fields known as coronal mass ejections. Think of them as billion-ton clouds of charged particles, primarily electrons and protons hurled into space at millions of miles per hour. When one of these solar storms is aimed directly at Earth, it takes a day or two to travel the vast distance between worlds. Upon arrival, it slams into our planet's protective magnetic shield, the magnetosphere. This collision funnels these energetic particles down the magnetic field lines toward the north and south poles, where they smash into atoms and molecules in our upper atmosphere. Each collision is a tiny burst of light, and billions of them together create the aurora. Oxygen atoms glow green or red, while nitrogen produces blue and purple hues. What makes a display truly major and visible at low latitudes is the strength of the solar storm. A potent coronal mass ejection can overwhelm the magnetosphere, bending and distorting Earth's magnetic field lines. This forces the auroral oval, the ring of light typically centered on the magnetic poles, to expand dramatically southward. During an extreme event, someone in Texas, Italy, or even the southern United States might witness the same dazzling show usually reserved for Alaskan or Scandinavian skies. The most powerful storm on record, the Carrington event of 1859, was so intense that auroras were seen as far south as the Caribbean, with newspapers reporting that the light was so brilliant miners in the Rocky Mountains woke up and started making breakfast believing it was morning. To have any chance of witnessing this rarity, you need to become a solar storm forecaster. Several excellent resources are at your disposal. The NOAA Space Weather Prediction Center issues alerts and forecasts on their website using a scale from G1, a minor storm, to G5, which is extreme. Your goal is a G4 or G5 warning. You can also follow astronomers and space weather enthusiasts on social media who often sound the alarm when a significant coronal mass ejection is on its way. When a major storm is predicted, your next task is to find a dark sky away from city lights with a clear view to the north or south if you're in the southern hemisphere. Be patient, as the peak of the storm can occur at any hour of the night. Capturing the aurora with a camera is easier than you might think and is a fantastic way to preserve the memory. Use a DSLR or a mirrorless camera with manual settings and mount it on a steady tripod. Set a wide aperture like f2.8 or lower, a high ISO between 1600 and 6400, and a shutter speed between 2 and 15 seconds, adjusting based on the speed of the light's movement. Use a wide-angle lens to capture the vast scale of the sky, and always shoot in RAW format for the best editing flexibility. A major low-latitude aurora is a gift from the sun, a reminder that we are intimately connected to our dynamic star, and a night spent under its shimmering curtains is an experience you will never, ever forget. Descending from the grand, atmospheric curtains of the aurora to a far more precise and diminutive alignment, we arrive at the transit of Mercury, the smaller but no less fascinating cousin to Venus's grand passage. This event, our number 10, sees the solar system's swiftest and smallest planet pass directly between Earth and the Sun, appearing as a perfectly round, incredibly tiny black dot inching with purpose across the face of our star. It's a test of observation, a demonstration of scale, and an event that connects us to the meticulous work of early astronomers who used these moments to map the heavens themselves. While a Mercury transit shares the same basic principle as a Venus transit, the experience of viewing it is entirely different, defined by two critical factors: size and frequency. Mercury is a much smaller planet and orbits closer to the Sun, which means from our perspective, its silhouette is a mere speck against the solar disk, only about 194th the apparent size of the Sun. Spotting it is impossible without magnification. You absolutely must use a telescope equipped with a proper, certified solar filter to observe this event safely. Through the eyepiece, the search becomes a thrilling game of Where's Waldo on a cosmic scale, scanning the Sun's face for that tiny, perfectly black pinprick making its slow, stately journey. Despite its small stature, Mercury offers many more opportunities to witness its transit than Venus does. Due to its faster orbit, Mercury transits occur about 13 or 14 times each century, far more frequent than the century-spanning pairs of Venus transits. The pattern is somewhat irregular, with transits only possible in early May or mid-November when Earth's orbit aligns with the nodes of Mercury's path. Yet, for any single observer, catching one remains a significant rarity. Cloudy weather, the transit occurring during nighttime for your part of the world, or simply not having the right equipment ready can easily cause you to miss several in a row. This makes planning for a Mercury transit an event in itself, a date with the cosmos that requires preparation and a bit of luck with the forecast. This celestial phenomenon played a crucial, though often overlooked, role in the history of astronomy. While the transit of Venus was the key to unlocking the absolute scale of the solar system, the transit of Mercury provided astronomers with a powerful tool for refining their understanding of planetary orbits and physical characteristics. By carefully timing the exact moments of first contact, when the planet's edge first appears to touch the Sun, and final contact, when it completely leaves the solar disk, from different locations on Earth, scientists could calculate Mercury's distance and orbit with incredible precision. These observations also helped astronomers deduce that Mercury must have an extremely thin atmosphere, or perhaps none at all, because unlike Venus, which shows a visible aureole or ring of light around its limb during a transit due to its thick atmosphere, Mercury presents a sharp, crisp silhouette against the Sun, confirming its status as a bare, airless rock. For the modern observer, the next chances to see this event for yourself are already on the horizon. The most recent transits occurred in May of 2016 and November of 2019. Looking ahead, mark your calendars for November 13th, 2032 and November 7th, 2039. To prepare, you'll need access to a telescope. Many local astronomy clubs host public viewing events for these occasions, and you must ensure it is fitted with a professionally manufactured solar filter that covers the entire front aperture of the telescope. Never, under any circumstances, look at the Sun through an optical device without proper protection. Witnessing a Mercury trance, it is a lesson in patience and precision, a chance to see the clockwork of our solar system in action on the smallest of scales, a tiny black dot on a grand yellow canvas writing its own quiet chapter in our ongoing exploration of the cosmos. Just when you think you've seen the most precise event possible with the Moon's occultations, the cosmos unveils an even more specialized and heart-pounding variation, the grazing lunar occultation. This is our number 11 event, and for those fortunate enough to be stationed in exactly the right place at exactly the right time, it offers a performance of such intricate beauty and scientific value that it feels like a private show from the universe. Unlike a standard occultation where a star vanishes cleanly behind the Moon's disk, a graze occurs when the star's path merely skims the Moon's northern or southern limb. From our vantage point, the star doesn't simply disappear. It dances along the rugged lunar topography, flickering in and out of view as it passes behind mountains and peeks back out through valleys, creating a stunning, rapid-fire light show that is utterly mesmerizing through a telescope. The visual experience is unlike anything else in astronomy. You train your telescope on a specific point along the Moon's dark edge, your eye glued to the eyepiece. As the predicted moment arrives, the star approaches the lunar limb. Instead of a single, clean disappearance, the point of light begins to flash. It might vanish for a second as a 1-mile-high mountain on the Moon blocks it, then reappear brilliantly for a moment as it crosses a valley, only to vanish again behind another peak. This sequence can repeat dozens of times over a few seconds, a rapid, twinkling ballet of light and shadow that directly reveals the dramatic and uneven nature of the Moon's surface. It's a direct, real-time demonstration that the Moon is not a smooth billiard ball, but a world of immense craters, towering peaks, and deep ravines. This breathtaking display is far more than just a visual treat. It is a cornerstone of a field called astrometry, the precise measurement of the positions and motions of celestial bodies. By carefully recording the exact timings of each disappearance and reappearance during a graze from multiple locations, teams of amateur astronomers can provide professional researchers with incredibly valuable data. This collective effort allows scientists to map the lunar limb profile with sub-kilometer accuracy, refining our understanding of the Moon's exact shape and orientation in space. Furthermore, these precise timings help to nail down the exact position of the star itself in the sky, contributing to our ever-improving catalog of celestial coordinates. In some cases, a graze can even reveal that a star thought to be single is actually a very close binary system, as the light may flicker in a distinct double pattern as it grazes the Moon. To be part of this elite group of observers, you must embrace the role of celestial cartographer and adventurer. The paths for witnessing a specific graze event, known as the northern and southern limits, are extraordinarily narrow, often less than a half-mile wide on the Earth's surface. This means you might have to drive to a very specific field, roadside, or hilltop to position yourself correctly. The International Occultation Timing Association is the global hub for these predictions, providing detailed maps that plot the graze path across the landscape with impressive accuracy. Your mission is to use these maps, often with GPS coordinates, to find your exact observing site. The best way to participate is to join a group expedition organized by a local astronomy club, where experienced observers can help with the complex planning and timing. You'll need a telescope, a steady mount, a stopwatch synchronized to an atomic clock signal, and a keen eye. The reward for this meticulous effort is a front row seat to one of the most dynamic and personal astronomical events possible, a moment where you are not just a spectator but an active participant in measuring the solar system. Shifting our gaze from the ancient natural clockwork of the heavens to a more recent and entirely human-made phenomenon, we arrive at a spectacle that, for 2 glorious decades, offered a unique kind of magic. This is the Iridium Flare, our number 12 event, a historical footnote now, but one that captivated sky watchers around the world with its predictable, stunning brilliance. For a brief moment in astronomical history, we had created our own man-made star that could, on command, outshine everything in the night sky except for the moon, igniting with the intensity of a welder's torch in the deep black of space. The mechanics behind this incredible flash were a beautiful accident of engineering. The Iridium satellite constellation was a network of 66 communication satellites, named for the element iridium, which has 77 electrons, originally planned to be 77 satellites. Each of these spacecraft was equipped with 3 highly polished, door-sized antennas designed to reflect radio signals, but they also reflected sunlight with incredible efficiency. The magic happened when one of these antennas acted like a gigantic curved mirror orbiting 500 miles overhead. If the geometry was just perfect, if the satellite, the observer on the ground, and the sun were all aligned precisely, that mirror would catch the rays of the sun, which was just below the horizon for the observer on the ground, and focus them into a concentrated beam of light that shot directly down to your location. This wasn't a faint, fleeting glint. A full iridium flare could blaze at an astounding magnitude -8 or even brighter. To put that in perspective, the planet Venus, the brightest natural object in the night sky, shines at about magnitude -4. The International Space Station, a brilliant sight itself, reaches around -6. An iridium flare could be up to 60 times brighter than Venus, appearing as a star that would rapidly brighten in a specific patch of sky, hold its breathtaking peak for a few seconds, and then just as swiftly fade back into nothingness. The best part was its perfect predictability. Websites and apps could tell you the exact second to the very minute when a flare would occur, its precise path across the sky, and even how bright it would become. This created a global community of flare chasers who would set alarms to step outside and witness these daily celestial performances, sharing their photos and experiences online. That era, however, has now passed. The original Iridium constellation has been decommissioned and deliberately deorbited, burning up in the Earth's atmosphere to reduce space debris. The last first-generation satellite was brought down in 2019, bringing a definitive end to the age of the classic Iridium flare. We are left with a new generation of satellites that serve our communication needs but lack those magnificent reflective antennas. Their passes can still be interesting to watch, and the massive constellations like Starlink can create their own eerie trains of moving lights shortly after launch, but none can replicate the sheer, jaw-dropping intensity of a perfect Iridium flare. While we can no longer look forward to these events, their legacy endures. They taught an entire generation the joy of looking up and appreciating the dynamic nature of the sky, proving that wonder could be found in the most unexpected places, even in our own technology. They also serve as a poignant reminder that our night sky is changing. As new mega-constellations are launched, the pristine darkness that has inspired humanity for millennia is being altered. The story of the Iridium flare is a closed chapter, a beautiful, fleeting moment in our relationship with the cosmos that reminds us to cherish the quiet, dark skies we still have and to always find wonder in the predictable and the unpredictable movements of lights above. While the silent, predictable arcs of satellites are a marvel of modern engineering, the universe sometimes throws a far more primal and heart-stopping spectacle our way. This brings us to our number 13 event, the Earth-grazing meteor fireball, a cosmic bullet that transforms the entire sky into its shooting gallery. Forget the quick, half-second streak of a typical meteor. An Earth-grazer is a languid, dramatic performance. It's a brilliant fireball that appears on one horizon and seems to take its sweet time, often 10 seconds or more, to sail across a vast expanse of the heavens before finally vanishing near the opposite horizon, leaving behind a ghostly train of ionized gas that can linger for minutes. What you're witnessing is a matter of angles and physics. Most meteors are tiny particles that hit Earth's atmosphere head-on, vaporizing instantly in a quick, straight-line flash. An Earth-grazer, however, is typically a larger piece of space rock, perhaps the size of a football or bigger, that approaches our atmosphere at an incredibly shallow angle, just 5 to 10 degrees above the horizontal. Instead of plunging straight in, it literally skips across the upper layers of our atmosphere like a flat stone skimming across a calm pond. This shallow entry allows it to travel an extraordinary horizontal distance, sometimes over 600 miles, all while superhealing from friction with the air. This prolonged interaction is what creates the extended, awe-inspiring show, with the fireball often fragmenting under the immense pressure, creating a procession of multiple glowing chunks. The visual display is utterly captivating and often intensely colorful, as the meteoroid violently compresses the air in front of it, heating to temperatures exceeding 3,000 degrees Fahrenheit. It doesn't just glow white. Different minerals within the rock vaporize and emit specific colors. Magnesium burns with a brilliant blue-white light, calcium radiates a violet hue, and nickel can produce a vivid green. This can cause the fireball to flicker and shift colors as it travels, a stunning rainbow of incandescent gas. The sheer violence of this atmospheric entry can also produce audible sounds. If the object is large enough and close enough, observers on the ground might be treated to a series of deep, rumbling sonic booms that arrive several minutes after the visual event has concluded, a powerful sonic signature of the incredible forces at play. This skipping stone action has two possible outcomes, both of which are thrilling from a scientific perspective. In many cases, the object loses enough velocity and material during its long, shallow dive that it eventually slows down and escapes back into interplanetary space, now on a slightly altered orbit around the Sun. It becomes a former meteoroid, forever changed by its close encounter with our world. The other, more tantalizing possibility is that fragments survive the entire fiery journey and reach the ground as meteorites. Because of the long, shallow path, the potential strewn field, the area where these space rocks might land can be hundreds of miles long, making recovery a challenging but exhilarating treasure hunt. This is where you, the observer, become a crucial part of the scientific process. If you are ever fortunate enough to witness one of these breathtaking events, your detailed report can be invaluable. Organizations like the American Meteor Society actively collect data from the public. As soon as you can, note the exact time, your location, the direction the fireball came from and vanished toward, its apparent brightness compared to planets or the moon, any colors you saw, and whether you heard any sounds. Even better if you are driving and have a dashcam, or if you have a security camera that captured the sky. That footage is pure gold for scientists. Your simple report can help astronomers triangulate the object's path through the atmosphere, calculate its original orbit around the Sun, and even pinpoint a potential landing zone for meteorite recovery teams. Witnessing an Earth-grazer is a rare privilege, but reporting it transforms you from a spectator into a citizen scientist, helping us all gather pieces of the cosmos. Imagine the ultimate 2-for-1 celestial deal, a night where the cosmos seems to show off by staging two of its greatest shows simultaneously. This is the incredibly rare convergence of a total lunar eclipse and a major meteor shower peak, our number 14 event. Picture yourself lying back in a reclining chair, your eyes adapted to the darkness. Above you, the full moon has been transformed into a deep, coppery blood moon, its usual brilliant light softened to a dim, mystical glow by the shadow of our own planet. And across this now darkened celestial canvas, the occasional brilliant streak of a meteor from a major shower like the Perseids or Geminids suddenly scratches a line of pure white fire. You're not just seeing one event, you're witnessing a cosmic duet of shadow and light, a performance of profound patience and fleeting violence happening all at once. The reason this combination is so spectacularly rare boils down to two separate, unconnected cycles that must perfectly align. First, you need a total lunar eclipse, which itself only happens a few times a year and is only visible from about half the planet. Second, you need the peak activity of a major annual meteor shower. These showers are caused by Earth plowing through the debris trails of specific comets, and their peaks are incredibly narrow, often lasting just a few hours of maximum intensity. The real magic and the immense challenge is that the lunar eclipse must occur on the very night of that shower's peak, and it must be visible from a location blessed with clear, dark skies. The dimming of the moon during totality is the critical ingredient. A normal full moon is so bright that it washes out all but the very brightest meteors, drastically reducing the number you can see. But during a total eclipse, that overpowering lunar light is extinguished, allowing the fainter streaks of the meteor shower to shine through against a now properly dark sky. It turns a good meteor shower into a potentially great one, all while the main attraction, the eclipsed moon, hangs ominously overhead. For photographers, this night is the Holy Grail, offering a chance to create a single, unforgettable image that tells two stories. The technique involves a wide-angle lens to capture as much of the sky as possible, framing the haunting red moon alongside an interesting foreground element, like a mountain silhouette or a lone tree. With a camera on a sturdy tripod, you would take a long exposure to capture the dim light of the eclipsed moon and the starry background. The real hope is that during that exposure, often 30 seconds or more, a brilliant meteor will choose to streak through your frame, its path forever frozen in the final image alongside the moon. It's a shot that requires patience, planning, and an enormous amount of luck, but the result is a masterpiece of astrophotography that few will ever replicate. While there is no regular schedule for these events, they have gifted lucky observers with unforgettable memories in the past. One of the most celebrated pairings happened on the night of December 13, 1992, when a total lunar eclipse coincided with the peak of the Geminid meteor shower. Observers across North America who had clear skies were treated to the surreal sight of meteors flashing around the eerily dark moon. A more recent, and for many, more personal event occurred in the early morning hours of May 26, 2021. A total lunar eclipse, which was a supermoon to boot, happened to align with a minor, unexpected meteor outburst from the Tau Herculid shower. While the meteor activity wasn't storm level, many observers reported seeing bright streaks against the blood-red moon, creating a magical experience. To have a chance at witnessing this for yourself, your best strategy is to be an informed and prepared sky watcher. Keep a list of upcoming total lunar eclipses and the dates of major meteor shower peaks. When you see that an eclipse is forecast for a night near a shower's peak, that's your cue to start planning. The Perseids peak around August 12th every year and the Geminids around December 14th. If an eclipse is scheduled for those dates, you know you have a potential cosmic jackpot on your hands. Your success will depend entirely on the weather and your willingness to travel to find a clear sky. But the potential reward, a night spent under a dark, red moon while nature's fireworks explode around it, is worth every bit of the effort. It's a reminder that sometimes the universe's greatest gifts are the ones we never even thought to ask for. Now, imagine a celestial event that feels less like a dramatic performance and more like a perfect, living postcard from the solar system. A moment of serene beauty where a wandering planet pauses for a portrait against a backdrop of ancient, glittering stars. This is the pulse of a planet with a bright star cluster, our number 15 event, a breathtaking conjunction that offers a stunning visual contrast and a profound sense of cosmic depth. An pulse simply means two objects appear exceptionally close together in our sky, and when one of them is a brilliant, steady planet and the other is a famous star cluster, the result is a scene that has captivated astronomers and artists for centuries. The visual magic of this pairing lies in the beautiful juxtaposition of the two different types of objects. On one side, you have a planet, a bright, singular, and steady point of light, shining by reflected sunlight from our own solar system. It feels close, personal, and familiar, and right next to it you have a star cluster, a hazy patch of light that, even to the naked eye, hints at its true nature. But through even a simple pair of binoculars, that patch explodes into a glittering collection of dozens or even hundreds of distant suns, each a distant inferno in its own right. Seeing a world like Venus or Mars suspended right beside the delicate, sparkling mist of the Pleiades creates a powerful illusion of depth, a direct line of sight from our backyard to the stellar nurseries of our galaxy. Some of the most iconic clusters provide the perfect celestial stage for these encounters. The Pleiades, or M45, is perhaps the most famous. Often called the Seven Sisters, this open cluster is a tight-knit family of hot, young, blue stars, all born together from the same cosmic cloud and still drifting through space as a group. Its distinctive tiny dipper shape is recognizable even from light-polluted suburbs. Then there is the Beehive cluster, known as M44 or Precep. Located in the constellation Cancer, it appears as a soft, fuzzy glow to the naked eye, but transforms into a swarming hive of stellar points through optics. When a bright planet wanders into the same field of view as one of these clusters, it creates a photographic and visual opportunity unlike any other. To truly appreciate this event, you will want the right tools. A good pair of astronomy binoculars, like 7x50 or 10x50 models, is arguably the perfect instrument. Their wide field of view allows you to see both the bright planet and the entire star cluster simultaneously, creating that breathtaking planet in a starry nest effect. Through a telescope at low power, the view becomes even more immersive. You can watch the planet's disk, perhaps even seeing the phase of Venus or the rust-colored hue of Mars, surrounded by a sprinkling of diamond-like cluster stars. The contrast between the sharp, defined planet and the myriad of faint, distant suns is a constant reminder of the different scales at work in our universe. For those looking to capture this beauty with a camera, the Pulse offers a fantastic project. The goal is to use a lens with a fairly long focal length, perhaps 200 to 400 millimeters, to bring the scene closer while still keeping both the planet and the cluster in the frame. Mount your camera on a sturdy tripod and use a tracking mount if you have one to allow for longer exposures without star trails. Take a test shot to expose correctly for the bright planet, which will likely be the brightest object in the frame, and then take another to bring out the fainter stars of the cluster. Many astrophotographers will blend these exposures later to create a final image that shows the entire dynamic range of the scene in perfect detail. The best part is that you do not have to wait long for a chance to see this for yourself. These pulses happen with satisfying regularity as the planets continuously march along the ecliptic path, periodically passing by these fixed stellar landmarks. A very promising event is coming up on the evening of June 3, 2024, when the brilliant planet Mercury will pass just a few degrees north of the beautiful Pleiades cluster in the twilight sky. Then, on the morning of April 4, 2025, look for Mars making a very close approach to the Pleiades as well, offering a fantastic view for early risers. By consulting astronomy magazines, apps, or websites, you can easily find forecasts for these planetary meet-ups years in advance. Witnessing a planet snuggled up against a star cluster is a gentle yet powerful astronomical event, a quiet moment of cosmic alignment that beautifully illustrates the harmonious motion of our solar system within the greater Milky Way. While the serene pairing of a planet and a star cluster offers a quiet study in cosmic depth, the solar system is also capable of delivering a far more dramatic and personal planetary performance. This brings us to our number 16 event, the perihelic opposition of Mars, a celestial handshake where the red planet puts on its most spectacular show for Earth-bound observers. An opposition occurs when a planet outside Earth's orbit is directly opposite the Sun in our sky, rising at sunset and remaining visible all night, marking its closest approach to our world for that orbital cycle. But a perihelic opposition is the premium version of this event, a special cosmic alignment that makes Mars appear larger, brighter, and more detailed in our telescopes than at any other time. The extraordinary nature of this event is a direct result of the unique and slightly eccentric orbits of both Earth and Mars. Our paths around the Sun are not perfect circles, they are ellipses, meaning our distance from the Sun varies throughout the year. Mars has a significantly more elliptical orbit than Earth. Its closest point to the Sun is called perihelion, and its farthest point is aphelion. The magic of a perihelic opposition happens when Mars reaches opposition at the same time it is near its perihelion. In this perfect alignment, two factors work in our favor. Earth is near its farthest point from the Sun, making our world a bit smaller from Mars's perspective, and Mars is at its closest point to the Sun, making it significantly larger from ours. This dual effect causes Mars to swing exceptionally close to Earth, sometimes within 35 million miles. The visual difference for an observer is staggering. During an unfavorable aphelic opposition, when Mars is far from the Sun, its disk might appear a modest 15 arcseconds in diameter, tiny and challenging to detail in a telescope. But during a perihelic opposition, that disk can swell to over 24 arcseconds across. To the naked eye, it simply looks like an intensely bright, unwavering orange star dominating the night sky. But through a telescope, the transformation is breathtaking. The planet is no longer just a dot, it's a world. You can clearly see its bright southern polar ice cap, a gleaming white patch of frozen carbon dioxide. The dark, sprawling surface markings, once mistaken for canals by early astronomers, reveal themselves as vast, wind-swept plains of dark volcanic rock. You might even witness the occasional white patch of a water ice cloud forming over a giant volcano, or the subtle fading of surface features as a regional dust storm begins to brew and enshroud the planet. These super-close approaches are not annual events. They follow a predictable but patient cycle of approximately 15 to 17 years, a rhythm dictated by the celestial dance of our two orbits. The most recent perihelic opposition was in July of 2018, when Mars treated a global audience to its best appearance since 2003. That 2003 approach was historic, bringing Mars within 34.6 million miles of Earth, the closest it had been in nearly 60,000 years. The next opportunity for an exceptional view will come in June of 2033, followed by another in July of 2035. This makes planning for these events a long-term endeavor, a date on the calendar that dedicated Mars watchers circle years in advance. To make the most of these prime viewing windows, technique is everything. While even a small telescope will show the polar cap and some dark markings, a larger aperture instrument, around 6 to 8 inches or more, will reveal an incredible amount of detail. The key to sharp views is patience and steady air. Wait for Mars to climb high in the sky, away from the distorting effects of our atmosphere near the horizon. Use high-quality color filters to enhance contrast. A red filter can darken the blue-ish atmospheric haze and make surface features pop, while a blue filter can help highlight white clouds and the polar cap. Sketching what you see over the course of an evening is a fantastic way to train your eye to detect subtle details and to record the planet's rotation as features slowly drift across the disk. A perihelic opposition is more than just an astronomical event. It's an invitation to explore a neighboring world in stunning detail, a reminder that the planets are dynamic, ever-changing places, and that sometimes the universe offers us a front-row seat. While our own world experiences its share of dramatic weather, the true masters of meteorological fury are the gas giants, distant worlds where storms are measured not in miles, but in scales that could swallow our entire planet. This brings us to our number 17 event, the rare visibility of giant planetary storm systems. This is not about simply seeing a band on Jupiter. It's about witnessing a moment of intense, dynamic change on another world, watching as a colossal tempest erupts, evolves, and slowly fades across the face of a distant giant, all from the eyepiece of your own telescope. The canvas for this cosmic weather report is, of course, Jupiter, the solar system's premier gas giant. Its atmosphere is a churning, chaotic tapestry of cloud belts and zones, powered by immense internal heat and a rotation so fast the planet completes a day in just under 10 hours. This creates a tempestuous environment where storms are not the exception, but the rule. The king of them all is the Great Red Spot, a monstrous anticyclonic storm that has been raging for at least 400 years. While it has shrunk considerably over the past century, it remains a breathtaking sight, a massive, salmon-colored oval that you can watch transit across Jupiter's disk over the course of a few hours. Seeing it is a rite of passage for any amateur astronomer, a direct link to the observations of Galileo and Cassini. But the true magic lies in catching the new storms, the dramatic outbreaks that transform Jupiter's appearance. These can be sudden and stunning. You might point your telescope one night to see a familiar, calm band of clouds, and return a week later to find it ripped apart by a brilliant white plume that wasn't there before. These are massive convective outbreaks, where heat from deep within the planet forces vast columns of fresh, bright ammonia ice crystals to punch up through the upper cloud decks. Over weeks and months, these bright spots can stretch, evolve, and even change color, sometimes darkening into a reddish hue similar to the Great Red Spot itself. Saturn, though more subtle, offers its own surprises. Its normally placid, buttery-colored atmosphere can be interrupted by great white spots, enormous, bright storm systems that erupt roughly once every Saturnian year, which is about 30 Earth years. These storms can eventually stretch to encircle the entire planet, creating a dazzling belt of turbulence that is visible even in modest backyard telescopes. The thrill of observing these events is deeply connected to the practice of regular, patient monitoring. You are not just taking a single glance, you are becoming a chronicler of another world's weather. The key is to observe frequently, to learn the normal patterns of the planet's belts and zones so that you can immediately recognize when something is new or out of place. This might mean sketching what you see each night or taking detailed notes on the intensity and color of various features. The payoff comes when you are the first to notice a fresh, bright spot or a sudden darkening in a belt, a discovery that is genuinely thrilling. This is where your hobby transforms into genuine citizen science. Organizations like the Jupiter section of the British Astronomical Association or the Association of Lunar and Planetary observers actively welcome and rely on reports from amateurs worldwide. By submitting your sketches, images, and descriptions, you contribute to a long-term database that helps professional scientists understand the complex weather patterns and long-term climate cycles of these alien worlds. Your single observation from your backyard becomes a valuable data point in a global effort to understand the atmospheres of the gas giants. It's a powerful reminder that even in our modern age of space probes and giant observatories, the dedicated eyes of amateur astronomers still play a vital role in exploring our solar system. But just as the fiery temper of Jupiter offers a dynamic spectacle, The moon provides a far more patient and serene kind of performance, one where time itself seems to stretch to its very limit. This brings us to our number 18 event, the very long-duration lunar eclipse. We've already marveled at the central eclipse that plunges the moon deep into Earth's shadow. But this specific phenomenon takes that experience and extends it into an epic, almost meditative observance. Imagine the totality phase of a blood moon not lasting for a standard hour, but stretching for a breathtaking 100 minutes or more, giving you an unprecedented window to soak in the moon's haunting beauty under the stars. The secret to this incredible extension of time lies entirely in the moon's elliptical orbit around our planet. The moon doesn't circle us in a perfect circle. Its path is an oval, which means its distance from Earth varies. The closest point in its orbit is called perigee, often giving us a dramatic supermoon. The farthest point is apogee, resulting in a slightly smaller-looking minimoon. This difference in distance has a direct and profound impact on the moon's orbital speed, governed by the laws of orbital mechanics. When the moon is near perigee, it moves at its fastest along its path. But when it is near apogee, it is traveling at its absolute slowest. Now, picture the Earth's umbral shadow as a fixed circle in space. For a lunar eclipse to occur, the full moon must pass directly through this shadow. The speed of the moon as it makes this journey is the only variable that determines how long totality will last. This sets the stage for two very different eclipse experiences. During a perigee eclipse, the moon is moving at its quickest. It zips through the Earth's shadow, resulting in a relatively brief totality, sometimes as short as 30 or 40 minutes. It's a beautiful but fleeting event. The long-duration eclipse is the complete opposite. It occurs when a full moon coincides with or is very near its apogee. Moving at its most sluggish pace, the moon takes a long, leisurely stroll through the very center of the umbral shadow. It lingers in the darkness, allowing the coppery red glow to persist for what feels like an eternity. The maximum possible theoretical duration is around 106 minutes, and eclipses approaching this limit are the crown jewels for eclipse chasers who crave the longest possible time under the blood moon spell. For those eager to plan for this extended celestial meditation, the future holds some magnificent opportunities. One of the longest totalities of the 21st century occurred in July of 2018, with a duration of 103 minutes, offering a breathtaking show for much of the world. Looking ahead, mark your calendars for June 26, 2029. This central eclipse will feature a notably long totality of 102 minutes, providing an exceptional view for observers across the Americas, Europe, and Africa. Another fantastic event will grace our skies on July 7, 2047, with a totality lasting a stunning 101 minutes, a prime target for viewers in Australia, the Pacific, and the Americas. These are not just dates on a calendar, they are invitations to witness one of the most patient and profound events nature has to offer. To fully appreciate a long-duration eclipse, you need to shift your mindset from a quick observation to a full immersion. This is not an event to glance at for a few minutes, it's an experience to settle into. Set up a comfortable reclining chair or a blanket, bring warm drinks and dress in layers as the night will be long. Use the extended time to truly watch the subtle changes in the moon's appearance. Note how the color and depth of the red hue might shift as the moon moves through different parts of the umbra. The extended period also provides a perfect opportunity for lunar photography without rushing. You can experiment with different exposures to capture the faint details of the moon's surface under this dim, eerie light, or try your hand at a time-lapse that compresses the entire slow journey into a few seconds. A very long-duration lunar eclipse is a gift of cosmic time, a rare chance to slow down and lose yourself in the silent, graceful dance of shadows that connects our world to its closest celestial companion. From the vast, patient darkness of a long lunar eclipse, we now turn to one of the most precise and personally rewarding challenges an amateur astronomer can undertake: the asteroid occultation of a bright star. This is our number 19 event, a celestial high-wire act where a tiny, dark rock millions of miles away in our solar system's asteroid belt perfectly aligns with a distant, brilliant sun. For those positioned in an incredibly narrow path on Earth, the result is a breathtakingly sudden and precise disappearance, as the star winks out of existence for a few seconds, only to reappear just as abruptly on the other side. It's a direct, visceral measurement of the solar system happening in real time, right before your eyes. The sheer precision required for this event is almost beyond comprehension. You are trying to catch the shadow of an object that might be only 50 or 100 miles wide, cast from a distance of over 100 million miles. That shadow is incredibly narrow as it sweeps across the Earth's surface, sometimes no wider than the path of a total solar eclipse, but often much smaller. Successfully standing in that shadow path is the ultimate test of prediction and planning. The star involved is often a well-known bright point of light, easily visible in a small telescope or even binoculars. You watch it steadily, knowing the exact second the asteroid is predicted to pass in front of it. Then, if you are perfectly positioned, it happens. The star vanishes completely. Not a fade, not a flicker, but a clean, instantaneous off and on again switch being thrown in the depths of space. That moment of pure darkness is a thrill unlike any other in astronomy. This brief blink is far more than just a visual curiosity. It is a powerful scientific tool. By meticulously timing the exact duration of the disappearance from multiple locations across the shadow path, astronomers can reconstruct the silhouette of the asteroid with astounding accuracy. Think of it as a celestial sonogram. If observers at different locations report different lengths of disappearance, it reveals that the asteroid is not a perfect sphere, but is likely elongated or irregularly shaped. Sometimes, if the asteroid has a small moon orbiting it, a fact unknown until that very moment, the star might flicker twice, disappearing first behind the main body and then again behind its satellite. These events have even been used to discover and confirm binary asteroid systems, adding a whole new layer of understanding to these ancient building blocks of the solar system. Participating in this endeavor transforms you from a passive observer into an active contributor to planetary science. The key to a successful campaign is coordination through organizations like the International Occultation Timing Association. They provide detailed predictions and maps showing the predicted path of the asteroid's shadow, often just a few miles wide, across the globe. Your mission is to use GPS to position yourself precisely within that path, setting up your telescope, a video camera attached to it, and a dedicated time inserter that stamps each video frame with exact atomic time. The goal is to record the event, noting the precise moments of disappearance and reappearance to within a fraction of a second. This data, when combined with reports from other observers spread along the path, allows scientists to create a detailed profile of the asteroid, refining its orbit, determining its precise size, and unlocking the secrets of its shape. For those eager to join this elite group of cosmic cartographers, the best targets are occultations of bright stars by larger, well-known asteroids. Events involving stars brighter than magnitude 6 are ideal, as they are easy to see and provide a clean signal. The equipment needed is more specialized than for most hobbies. A moderate telescope, a sensitive video camera like an astronomy-specific CCD or a modified security camera, and a GPS-based time inserter are considered essential for serious data collection. But the reward is immense. The satisfaction of knowing your precise measurement, taken from your backyard, has directly contributed to our understanding of a distant world. It's a perfect blend of patient preparation, precise execution, and the sheer electric thrill of catching a shadow, making an asteroid occultation one of the most unique and intellectually satisfying events on our entire list. After the precise, timed blink of an asteroid occultation, we now turn our attention to a far more subtle and ethereal phenomenon, one that requires not precise timing but immense patience and the purest darkness on Earth. This is the zodiacal light and its elusive cousin, the Shouldnt, our number 20 events. These are not the sharp points of planets or the sudden streaks of meteors. They are the deepest, most fundamental glow of our solar system itself, a soft luminosity that proves we live not in a void, but within a vast, dusty disk surrounding our sun. The zodiacal light is the more accessible of the two, though seeing it is a true test of your sky's quality. Imagine yourself standing under a perfectly black, moonless sky, far from any city glow, perhaps an hour or two after sunset in the spring or before dawn in the autumn. Look toward the western or eastern horizon along the path that the sun and planets travel, the ecliptic. If conditions are perfect, you will see a faint, titanic, cone-shaped glow of soft, white light rising up from the horizon and stretching high into the heavens. It is often described as a faint, tilted pyramid or a ghostly spear of light. This is not the Milky Way, it is something far closer to home. This gentle radiance is sunlight, scattered toward us by countless billions of dust particles that orbit the sun in the inner solar system. These tiny grains, most no larger than specks of household dust, are the leftover debris from asteroid collisions and the evaporating tails of comets. They form a vast, flat cloud that fills the space between the planets, and the zodiacal light is our direct visual evidence of this celestial environment we call home. To have any hope of seeing this soft glow, you must commit to finding a truly dark sky. This is an observation that is utterly impossible from the suburbs or even rural locations with a distant glow of a city on the horizon. You need a Bortle Class 1 or 2 sky, a location where the heavens are so pristine that the Milky Way casts a faint shadow. The best times are during the zodiacal light seasons in the northern hemisphere. The evening sky in late winter and early spring after twilight has completely faded, or the pre-dawn sky in late summer and early autumn. The ecliptic must be steeply angled to the horizon, which is why these times of year work best. There must be no moon, and you must allow your eyes a full 30 to 40 minutes to become completely adapted to the darkness. Do not use any white light. A dim red flashlight is essential for preserving your night vision. Even with all these factors aligned, the zodiacal light is incredibly subtle. It is often described as being as bright as the faintest part of the Milky Way, but much broader and more diffuse. Do not expect a brilliant beam. Expect a faint, gentle intrusion on the perfect black of the night. A whisper of light that you see best by not looking directly at it, but rather by using your averted vision, gazing slightly to its side to allow your retina's more sensitive rods to detect its presence. If successfully spotting the zodiacal light is a badge of honor for deep sky observers, then seeing the Shouldnt is the ultimate master-level challenge. This phenomenon's name is German for counterglow, and it is an even more elusive component of the same interplanetary dust cloud. While the zodiacal light is sunlight scattered by dust particles in front of or behind us, the Shouldnt is a result of a different optical effect called opposition surge. It appears as an extremely faint, oval-shaped patch of light located at the point in the sky directly opposite the sun. In the middle of the night, this means it will be high overhead, nestled among the stars. The physics is fascinating. When the sun is directly behind us, its light strikes these distant dust particles head-on. This direct backscattering of light, much like the way a cat's eyes seem to glow in headlights, creates a slight brightening in that specific region of the sky. The Shouldnt is not a separate object. It is simply the brightest part of the entire zodiacal band. A faint girdle of light that can sometimes be traced all the way around the ecliptic, with the Shouldnt as its most prominent feature. Witnessing the Shouldnt is the pinnacle of visual astronomy, reserved for those who have access to the driest, highest, and darkest observatory quality sites on Earth, like the deserts of Chile or the mountains of Hawaii. It requires flawless transparency in the atmosphere, no humidity, no dust, no light pollution whatsoever. You are searching for a patch of sky that looks almost identical to the surrounding blackness, yet somehow not quite as black, a faint enhancement of the background that is more sensed than seen. For most of us, it remains a theoretical wonder, a testament to the sensitivity of the human eye under perfect conditions, and a humbling reminder of the subtle beauty that permeates the space between the planets. Seeing either of these phenomena is a profound experience. It connects you directly to the raw material of the solar system, the dust from which the planets formed, and the debris that continues to drift between them. It is a quiet, patient observation that rewards those who seek out true darkness, offering not a dramatic flash, but a deep and lingering connection to our celestial neighborhood. Just when you think you know what to expect from the night sky, it delivers a surprise that redefines the meaning of a meteor shower. This is the meteor shower outburst, our number 21 event. A breathtaking demonstration of cosmic unpredictability where a normally sleepy, minor stream of shooting stars suddenly erupts into a full-blown celestial tempest. Imagine settling in to watch a shower known for producing a paltry 5 or 10 meteors per hour, only to have the sky suddenly ignite with hundreds, even thousands of fiery trails. It's the ultimate astronomical jackpot, a reminder that the universe always has a few tricks up its sleeve for those willing to look up. These spectacular outbursts are not random acts of chaos. They are the direct result of our planet's orbit intersecting with a very specific and dense ribbon of debris. Think of a comet's path not as a smooth, evenly distributed river of dust, but more like a tangled skein of yarn. Over countless orbits, a comet sheds material, but it doesn't do so uniformly. Gravitational tugs from planets like Jupiter can clump this debris into dense, narrow filaments. Most years, Earth passes through the diffuse background cloud of this stream, giving us our reliable annual shower. An outburst occurs when our planet's path takes us directly through one of those incredibly dense, concentrated filaments. A cosmic minefield of particles that were likely ejected from the comet in a single, specific pass through the inner solar system, perhaps centuries ago. History is filled with legendary examples that turned obscurity into brilliance overnight. The Aurorid shower, typically a non-event with barely noticeable activity, shocked astronomers on September 1, 2007. For a brief, wondrous window, zenithal hourly rates skyrocketed to over 130 meteors, many of them stunningly bright and leaving persistent trains that hung in the air for minutes. Even more dramatic are the June Bartids, a shower associated with the comet 7P/Pons Winnock. Usually, it's a complete dud, but in 1998 and again in 2004, it produced unexpected outbursts with rates approaching 50 to 100 vivid, slow-moving meteors, captivating the handful of observers who happened to be watching. These events prove that any shower, no matter how feeble its typical performance, has the potential to become spectacular if Earth finds the right thread of debris. The thrilling endeavor of predicting these outbursts falls to a dedicated group of dynamicists, orbital mechanics experts like Jérémy Vorbelin at the Paris Observatory and others at NAS, a meteoroid environment office. Their work is a complex dance of gravitational mathematics. They take the known orbits of comets and then model how their debris trails have evolved over hundreds of years, calculating how the gravitational pull of the planets has shepherded and sculpted the dust. They can pinpoint years when Earth is likely to pass exceptionally close to one of these dense filaments, issuing forecasts for potential outbursts. However, these predictions always come with a degree of uncertainty. We can never be entirely sure of the density of particles within the filament until we actually hit it. This makes every forecast a compelling invitation, a chance to be part of a potentially historic observation. This is the most powerful lesson a meteor shower outburst teaches us, the immense value of simply showing up. The difference between missing a legendary event and witnessing it is often just the decision to go outside and look. many of the most dramatic outbursts have been witnessed by only a handful of people precisely because they occurred during the pre-dawn hours for a specific hemisphere, when only the most dedicated enthusiasts were awake and watching. The next great outburst could happen tonight during a shower you've never even heard of. This is why many seasoned meteor watchers make a habit of checking the forecasts for all minor showers, not just the famous Perseids or Geminids. They know that the reward for a few hours of patience under the stars could be a display that transcends any annual event, a spontaneous gift from a comet that passed by long ago, leaving behind a trail of cosmic treasure for us to discover. While the fleeting intensity of a meteor outburst captures our imagination with its sudden fury, the sky also stages a far more patient and graceful performance, a celestial minuet that unfolds over many weeks. This is the Triple Conjunction, our number 22 event, a rare and exquisite sequence where three planets engage in a series of close encounters, appearing to chase each other across the twilight sky in a display that beautifully illustrates the intricate mechanics of our solar system. Unlike a single, fleeting meeting, a triple conjunction tells a complete story of motion and rhythm, offering multiple opportunities to witness the planet's stately dance. The orbital choreography behind this phenomenon is a fascinating interplay of speed and perspective. Each planet moves along its orbit at a different pace. An inner planet like Mercury or Venus races around the Sun, while an outer planet like Mars, Jupiter, or Saturn takes a much more leisurely journey. A triple conjunction specifically involves two planets and the Sun, but from our moving vantage point on Earth, we see the two planets appear to meet not once, but 3 times over a relatively short period. This happens because of a combination of Earth's own motion and the apparent retrograde motion of the outer planet. As Earth overtakes a slower-moving outer planet, that planet appears to pause, move backward against the background stars, pause again, and then resume its forward motion. If a faster-moving inner planet is also in the same region of the sky during this celestial loop, the two will appear to draw close, separate as one continues on, then meet again during the retrograde period, and finally have a third and final encounter as their paths diverge for good. One of the most stunning and accessible triple conjunctions in recent memory involved the two brightest planets in our sky, Venus and Jupiter. These gas and cloud giants put on a magnificent show throughout 2015 and 2016. The sequence began with a breathtakingly close pairing in the evening sky of June 2015, where the two worlds were separated by less than the width of the full moon. As weeks passed, Venus, the speedier of the two, appeared to drop toward the horizon, leaving Jupiter behind. But then, as Earth's motion made Jupiter appear to begin its retrograde loop in the sky, Venus continued its own path, and the two seemed to reverse roles, drawing close together again for a second conjunction in the morning sky by late October. The grand finale occurred in the pre-dawn hours of early January 2016, with a third and final dazzlingly close pass, completing the triple conjunction sequence and providing a masterclass in celestial mechanics for anyone who had been following along. For astrophotographers and sky watchers, a triple conjunction is a dream event. It allows you to craft a stunning time-lapse or a composite image that tells the entire story of the planetary dance. You can capture the 3 key meetings, each weeks apart, and combine them into a single frame that shows the elegant, looping paths the planets traced relative to each other and the background stars. This not only creates a beautiful piece of art, but also serves as a direct visual proof of the Copernican model of the solar system, showing the planets in motion around the Sun rather than fixed to a celestial sphere. The best way to follow such an event is to note the dates of each predicted conjunction and make a point to observe the sky at regular intervals, perhaps once a week, to mentally connect the dots and watch the story unfold in real time. The beauty of a triple conjunction lies in its accessibility and its power to reveal the clockwork of the heavens. You don't need a telescope to appreciate it. Your own eyes are perfect. Simply knowing when and where to look is enough. These events are not as exceedingly rare as a transit of Venus, but they are special enough to be noteworthy, occurring for a given pair of planets perhaps once or twice in a generation. The next significant triple conjunctions will involve Mars and Saturn in 2036, and then Venus and Mars in 2041. By marking your calendar and committing to watching the slow, graceful dance, you become part of a long tradition of observers who have used these celestial meetings to measure the years and comprehend our place in a beautifully ordered, constantly moving solar system. It is a patient observer's reward, a story written in light that takes months to tell. After witnessing the grand, orchestrated dances of planets, we now turn our attention to a phenomenon of exquisite subtlety and fleeting beauty, a moment of pure magic that occurs in the blink of an eye at the very edge of our world. This is the legendary green flash, our number 23 event, a sublime atmospheric trick that transforms the simple act of watching a sunset into a potential treasure hunt for one of nature's most elusive and radiant colors. The science behind this emerald glimpse is a breathtaking demonstration of light bending through the ocean of air we call an atmosphere. It all comes down to a principle called refraction. As sunlight enters Earth's atmosphere, it slows down and bends, much like a straw appears to bend in a glass of water. But sunlight isn't just one color, it's a rainbow. Each color has its own wavelength, and each wavelength bends by a slightly different amount. Violet and blue light bend the most, while red and orange bend the least. Normally, when we look at the sun, these colors all blend together to create the familiar white light. However, when the sun is right on the horizon, its light is passing through a much thicker slice of atmosphere, maximizing this bending or prism effect. The atmosphere itself then acts as a filter. The shorter wavelengths, the blues and violets, are scattered in every direction by molecules in the air, which is why our sky is blue. This scattering removes them from the equation. What's left are the longer wavelengths, the yellows, oranges, and reds, which give the sun its iconic ruddy hue at sunset. So where does the green come from? In the final second before the sun completely disappears, its very top edge is still visible. The red and orange light from this sliver is bending just enough to pass directly below your line of sight. The yellow light bends a bit more, passing a little closer, but the green light, occupying a sweet spot in the spectrum, is bent just perfectly to shoot straight into your eyes for a breathtaking split second. You are essentially seeing a single, magnified wavelength of light from the very last fragment of the sun, isolated and intensified by the atmosphere itself. In even rarer conditions, a similar effect can produce a blue flash, which occurs in exceptionally pure air where even more of the blue light has managed to avoid being scattered away, allowing it to reach your eyes. To be in with a chance of witnessing this event, location and conditions are absolutely everything. You need a perfectly flat, unobstructed horizon. The open ocean is the classic and most reliable theater for this performance, but a very distant, perfectly flat prairie or a calm lake can also serve as a stage. The air must be incredibly clear and stable. Any haze, dust, pollution, or even high, thin clouds will scatter the delicate green light and ruin the effect. The best times are often after a rainstorm has washed the air clean, or in polar regions where the cold air is exceptionally transparent. Most importantly, you must never look for the green flash while the sun is still a discernible disk. It is only safe to look in the final 1 or 2 seconds before it vanishes completely, when the sun's intensity is reduced to a harmless level. The entire event is a lesson in patience and peripheral vision. It's about relaxing your gaze on the horizon, not staring directly at the sun, and waiting for that instantaneous electric jolt of pure emerald light to surprise you. This pursuit has become a rite of passage for sailors, pilots, and avid travelers, a moment of quiet victory against the odds. It has been romanticized in stories and films, often portrayed as a mystical sign or an omen. In reality, it is a gift of perfect atmospheric geometry, a reminder of the beautiful physics that plays out around us every single day, hidden in plain sight. It requires no special equipment, only your own attentive eyes, a clear horizon, and the willingness to truly watch the day come to a close. The green flash doesn't announce itself. It must be earned through patience, and its reward is a memory of a color so vivid and pure. It feels less like something seen and more like something felt, a brilliant green farewell from the sun, promising its return. But while the fleeting green flash rewards those who watch the sun depart, a different kind of challenge awaits in the opposite direction, moments after the sun has left the stage. This brings us to our number 24 event, the hunt for the record-breaking lunar crescent. This is not about finding the moon when it's an elegant sliver in the evening sky. This is a high-stakes game of celestial hide and seek, an attempt to spot the youngest moon possible, a filament-thin curve of light visible just hours after the moment of new moon, a sight that pushes the limits of human perception and atmospheric perfection. The challenge is one of breathtakingly difficult geometry. The new moon occurs when the moon is positioned directly between Earth and the sun, its sunlit side facing entirely away from us. To see it as a crescent, it must have moved far enough out from this alignment so that a sliver of that sunlight can reflect off its surface toward us. However, it is still incredibly close to the sun in the sky, meaning it sets very soon after the sun does, buried deep in the bright twilight glow. You are essentially trying to detect an absurdly thin, faint curve of light against a still illuminated background, positioned just above the turbulent, murky horizon. The factors required for success are a perfect storm of conditions, an exceptionally clear and transparent atmosphere free of dust and haze, a perfectly flat western horizon with no obstructions like mountains or buildings, excellent eyesight, and knowing exactly where to look. Even then, optical aid is almost a necessity, with binoculars dramatically increasing your chances by gathering more light and cutting through the twilight glare. This pursuit has given rise to a fascinating subculture of amateur astronomers dedicated to setting and breaking records. The youngest moon ever seen with the naked eye, verified by multiple independent observers, was just 15.4 hours old. To put that in perspective, that is a crescent illuminated on less than 0.8% of its surface, an arc so thin it is barely more than a curved line of light. With the aid of optical instruments like telescopes, the record pushes even further into the impossible. The legendary American astronomer Stephen James O'Meara claimed a sighting of a moon just 12 hours old using a telescope, a record that stands as a testament to skill and perfect conditions. Modern attempts often involve photography, where sensitive cameras can capture the crescent even earlier, but the visual sighting remains the ultimate bragging right, a moment of pure personal triumph against the odds. Beyond the sheer thrill of the hunt, the sighting of the new crescent carries immense cultural and religious weight across the globe. For Islamic communities, the sighting of the Hilal, the crescent moon, marks the beginning of sacred months like Ramadan and Shawwal, dictating the start of fasting for Eid al-Fitr. Jewish calendars also traditionally relied on eyewitness accounts of the new moon to declare the start of each new month. This ancient practice connects modern observers to millennia of human tradition, where entire communities would send witnesses to high hilltops to scan the twilight sky, their reports shaping the rhythm of religious and civic life. To participate in this hunt today is to join that long, unbroken chain of skywatchers, using modern knowledge but the same naked human curiosity to find that first sliver of light that heralds a new cycle. To undertake this monthly challenge yourself, you will need more than just luck. Preparation is everything. Use astronomy software or apps to know the precise time of the new moon and the moon's predicted altitude and azimuth at sunset for your location. The best opportunities come in the spring when the ecliptic, the path of the sun and moon, meets the evening horizon at a steep angle, lifting the moon higher into a darker sky. Wait for a day when the air is crystal clear, perhaps after a cold front has passed through. Find a viewing location with an absolutely unobstructed western view, like a large body of water or a wide open plain. As the sun sets, begin scanning the sky about 10 degrees to the south of where the sun disappeared, slowly sweeping upwards with binoculars. You are looking for that ghostly, ephemeral curve, a signature of delicate light that feels more like a memory than something real. If you find it, you have won one of astronomy's most satisfying prizes, a fleeting glimpse of a new beginning etched in silver against the twilight blue. And so our journey through the cosmos comes to a close, a whirlwind tour of celestial mechanics, cosmic violence, and breathtaking beauty that reminds us just how active and alive our universe truly is. From the patient, predictable dance of planets to the heart-stopping surprise of a great comet or a supernova's final farewell, we've witnessed the incredible diversity of performances the sky has to offer. Some of these events are like sold-out concerts, requiring tickets booked years in advance and journeys across the globe to sit in the narrow path of totality or the shadow of an asteroid. Others are spontaneous gifts, cosmic lightning strikes of chance that reward the simple, daily act of looking up with a memory that lasts a lifetime. This beautiful dichotomy is what makes astronomy so profoundly human. It connects our deepest love for planning and understanding with our childlike capacity for wonder and surprise. The key to catching these events is no longer a secret held by astronomers in ivory towers. It's in your pocket. Staying informed has never been easier, thanks to a wealth of incredible resources designed for everyone. Apps like Stellarium Mobile or Sky Safari can show you a real-time map of the heavens above you, identifying planets and stars with a tap. For precise alerts on things like meteor showers, occultations, and satellite flares, websites like the American Meteor Society or Heavens Above, COM are invaluable. Organizations like NASA and the Jet Propulsion Laboratory offer detailed calendars of planetary movements and lunar phases, while local astronomy clubs remain one of the best ways to connect with fellow enthusiasts. Learn how to use a telescope and get notified of those last-minute, can't-miss events. The universe is putting on a show, and with a little help from technology and community, you'll always have a front-row ticket. This isn't just about observing, it's about participating in a tradition as old as humanity itself. Every time you step outside to watch an eclipse, track down a faint planet, or simply stare up at the Milky Way, you are adding your story to an ancient and ongoing conversation with the cosmos. You become part of a chain that connects the builders of Stonehenge, the astronomers of Babylon, and the pioneers of modern science. So now we want to hear from you. What is the most unforgettable sight you've ever witnessed in the night sky? Was it a meteor so bright it left you speechless, the eerie calm of a total solar eclipse, or the first time you saw the rings of Saturn with your own eyes? Share your story in the comments below. Let's create a collective tapestry of wonder. And if you've enjoyed this guide to the universe's greatest hits, make sure to subscribe and hit the notification bell. Our journey doesn't end here. There are always more mysteries to unravel, more wonders to discover, and more cosmic